So this is the third video in which we'll actually this time look at a little more closely the difference between average and instantaneous velocity. We talked about this in the fall when we introduced the idea of velocity, but in order to understand acceleration, it's really good to revisit this topic. So the basic difference between average velocity and instantaneous velocity is a matter of time and the length of time that you're discussing. So the idea of average implies that we're looking at the velocity over a long time interval. So, for example, if I drive into Boston, my average velocity is probably about 30 miles per hour. However, if we consider that trip, my velocity is not always 30 miles per hour, and that's where we need instantaneous velocity. So instantaneous velocity is the velocity at a single moment in time. So if we were taking this trip driving to Boston, instantaneous velocity would be, I look at the speedometer and it tells me it reads 65 miles per hour just as I pass Fenway Park. In other words, that 60 miles, 65 miles an hour would be figured into the 30 mile an hour average, but it's just that velocity right at the moment I read it off of the speedometer passing Fenway Park. An analogy we often use is at the end of the term, I have to report an average for students, and that average is representative of all the work you've done this term. The instantaneous values would be the grades you get on the first quiz, the second quiz, the third quiz. But then we go ahead and calculate an average over time, meaning the whole term. Some symbols to be aware of. Average velocity is written like this, V with a bar over it, versus instantaneous velocities will now be written with subscripts, V1, V2, meaning first velocity, second velocity. So when we calculate acceleration, so let's talk about calculations. When we calculate accelerations, this is based on average velocity, or sorry, this is based on instantaneous velocity. So we're looking in it for a change in the instantaneous values. Earlier this year, when we used this equation, v equals d over t, which was often rewritten as d equals v times t, this actually should be v average. And we didn't distinguish because we didn't need to at that point. Now we do. So it's important to note that this is average velocity. Lastly, there's another way to calculate average. If you are in French class and you get an 80 on a quiz and then you get a 100 on the next quiz, intuitively, I think you know that your average would be a 90. So we did 80 plus 100 and divided by 2. We can find average velocity by taking the numerical average, meaning math class average, how you would take an average outside of physics. And that would just be v1 plus v2 divided by 2. So this is the mathematical way of calculating average. So I'm going to go ahead and do a practice problem here. Get out pencil and paper so you can do it with me. I have a car. And it starts at rest. And it accelerates. So the car at 3 meters per second squared. And let's go ahead and do this for 7 seconds. So the car is going to speed up going this way. And the two things I want to know are what is V2 after 7 seconds, and what is V average for that 7-second interval. So go ahead, take a minute, do this, and come back. So you're back. V2 is the instantaneous velocity at 7 seconds, or you could say after 7 seconds. And so I'm going to use the acceleration equation, and I'm going to solve for V2. Remember, this sometimes is a hard equation to manipulate to get to V2. I did this in the last video if you need a refresher. I'm essentially going to isolate V2 by multiplying through by time and adding V1. So I end up with AT plus V1 equals V2. So in this case, we have 3 meters per second squared times 7 seconds. And my initial velocity was 0. So my final velocity, V2, would be 21 meters per second. You could also count this number out in your head, remembering that 3 meters squared, the acceleration means the car gains 3 meters per second of speed for each second it accelerates. So you could count after 1 second, it would be going 3 meters per second. After 2, it would be going, write it out like this. After 2 seconds, it would be going 6 meters per second. After 3 seconds, it would be going 9. You can count all the way up, and you'd eventually get to 21. So that's the instantaneous velocity at 7 seconds. The average. So the other thing we need to figure out is what is the average for the entire 7-second interval. So this is like reporting an average for a trimester. Well, in order to calculate average, I'm going to use the math version of how to calculate average. So V1 plus V2, divide by 2. V1 is 0. V2 was 21. Divide by 2. 21 divided by 2 is 10.5. Now this value will be useful in the next lesson because this will allow us to find out how far the car moves. And that is the end of the lesson on instantaneous and average velocity.